Hi, boys and girls. Welcome back to the Fossil Webquest website. This is video number 2 of the Fossil Webquest. In the first video, if you look on the left-hand side of my screen, this is what was covered. We talked about what is the fossil record, becoming a fossil, protection and destruction, hardness of structures, where death occurs, and now we are ready to continue on to cover the remaining 3, 4, and 5 items on our kind of table of contents over here on the left. Okay, so I'm leaving right off from where I left off. I'm continuing on from there. So we know that paleontologists, right, someone who studies fossils, estimate that fewer than 10% of all organisms alive today will be preserved as fossils. Remember, not all types of organisms preserve well. Insects make up a very large percentage of all animals, but very few of them are likely to be preserved as fossils. On the other hand, organisms like vertebrates, that means they have a backbone. Okay, and vertebrate does not mean means they do not have a backbone. So vertebrae means you have a backbone. So humans would be considered vertebrae. Will leave a more complete record of their existence, even though they are less abundant. Paleontologists keep this in mind when interpreting fossil evidence. So they can get a more accurate picture of life in the past. So this is why fossils are important. It helps us to understand how life existed millions of years ago, and it helps us to understand how life has changed. So if we look at fossils from different time periods, we can kind of see organisms evolving or changing over time to be better suited to their environment. So living things evolve because of their environment. If their environment changes, they have to evolve to fit into their environment, or they will end up dying and not being able to survive. Even if a fossil is formed, it can easily be destroyed because the Earth is very dynamic. Fossils can get crushed. Notice how I can click on crushed. A box should appear. If a fossil is buried by too much sediment, it may become flattened or distorted beyond recognition. So that means we might not be able to tell what it even is if there is too much sediment there. So this is the crushed remains of an ancient mammal skull. It can become melted. Eventually, the rock might be buried deeply and undergo extreme pressure and heat, become metamorphic. The rock itself changes, and any fossils within are likely to be melted. Moved. Once fossils are formed, they can be moved in many different ways. For example, they can be washed away by streams, moved by glaciers, carried by scavengers. Again, those are organisms that eat living things. Usually, these are carnivores that eat meat. So these are the things that don't really like plants so much, but they like meat, or caught in rock slides. Plate tectonics can also move fossils. Plate tectonics can cause fossils that were once a part of the ocean floor to be found at the bottom of a mountain. Let's read that again. Plate tectonics can cause fossils that were once a part of the ocean floor to be found at the top of a mountain. This happens with uplift, tectonic uplift. So when two plates are going at each other, they're going to buckle, they're going to kind of fold on top of each other. Or eroded. Weathering by wind, water, and the sun can destroy a fossil by wearing it away. This is a fossil shell of a turtle. The upper part is darker and more complete. It was still covered by dirt and thus protected from weathering when the fossil was found. The lower section has been eroded and bleached by exposure to the sun. Before paleontologists can identify and study fossils, they have to find them. If an organism becomes a fossil, and if the fossil survives Earth's forces, then it has a chance of being found. But you can't find fossils in every type of rock. Many paleontologists start their research by finding areas that have the type of rock likely to contain fossils. we know the three types of rock are igneous, sedimentary, and metamorphic. Click on each of the pictures of rock to learn what type of rock they are. Igneous, produced when molten rock, magma, which is below ground. Lava is the same substance, it's just above ground. So magma and lava are the same thing. Magma below Earth's surface, lava above Earth's surface. When they cool and harden and solidify, they form igneous rock. Sedimentary, layers of small particles sediment compressed and cemented together. Metamorphic, any type of rock changed by heat and pressure. So metamorphic rock happens underneath the ground, and when heat and pressure from the rock above it can change its form. Click on the name of the rock that is most likely to contain fossils. Well, considering fossils get buried under layers, I would have to go with sedimentary. And I'm right. Most fossils are found in sedimentary rock. Organisms or traces can be preserved in sedimentary rock layers, allowing fossilization to occur. Paleontologists have to find rocks of the right age for what they are studying. As we have seen, fossils can't be found in every type of rock. Fossils need to be in the right type of rock, sedimentary. And since creatures live at different times, paleontologists must also look for rocks of the right age. So how do paleontologists know where to look? Geologic maps help paleontologists to find the right rocks for their question. So we want to look for sedimentary rock. Geologic map. Take a look at this geologic map of Montana. The different rock colors represent the rocks that we can see at the surface, both by age and type. Imagine that you are a paleontologist in search of the T-Rex, Tyrannosaurus Rex. Where would you start to look? Well, I definitely want to look for sedimentary. So I see sedimentary, 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 igneous, igneous, metamorphic. So I want to look for this color, green and yellow. All right. Correct. There are a lot of sedimentary rocks from the Mesozoic in Montana. These rocks are in the right age and type to preserve the fossil of a T-Rex. All right. Even when sedimentary rock from the right age are located, fossils have to be exposed before they can be found. Because of processes like uplift and erosion, some fossils that were once buried deep in the ground can become exposed near the surface. This is why many paleontologists look for fossils on the sides of hills and other areas where uplift and erosion have occurred. Even if a paleontologist look in areas likely to contain fossils, many fossils may never be found. One reason for this is that there are large areas to search. Paleontologists might turn over many rocks or dig in many areas to find the fossils that they do. It's not always easy to look. Many fossils remain undiscovered. Paleontologists understand that there are many reasons why the fossils they find represent only a partial picture of life in the past. Don't forget, boys and girls, if you would like to pause this video at any time, feel free to do that. You can rewind or fast forward. So here we have a nice little chart to review what we learned about. Organism dies. It could get decomposed. It could get destroyed. It could get covered in sediment, ice, or stuck in tree sap. And even that could get destroyed. Or it could become a fossil and stay a fossil, but it has to be exposed, the surface, for it to be found. So if you would like to take the quiz, you may. This is optional, so I will let you do this on your own. Okay, you do not have to take the quiz. You just have to answer the questions and submit it. But if you would like to kind of quiz yourself, please feel free to do so. It also might help you answer the questions a little bit quicker since you already know what you're talking about. Okay, I hope this video helped you, and I am looking forward to receiving your submissions and looking to see how much you learned.